Hello, in this video we are going to talk about the volatile and the synchronized keywords and what is the difference between the volatile and synchronized keywords in Java. So here is a program that we have, a main program. So in this one what we'll be doing is we'll be running the main method. We will create a thread and we will start the thread. So if you see the syntax of the code, so we have starting a thread and we have a scanner here, a scanner class. So what this will do is it will read the user input while running the program. So here we will be passing the system in, and as long as the scanner receives the next line, the program will be running, this thread will be running. So if you see in this thread, we have this run method and we have the boolean flag as the valid flag as true. So when you start the thread, what happens is it will call the run method, and as long as this is valid, as long as this boolean is true, it will keep on printing this statement, system out println statement, and only if this is false, the run method would stop. So once it prints, the thread would sleep for 50 milliseconds. So let's see how this runs. If you see this line here, stop execution, when we call this method, what we are doing is we are changing the value of the valid flag to false, so that the execution would come out of this loop and it will stop the print. Let us run this one. Okay, so it will keep on writing the same statement again and again. Now what we will do is we will try to hit enter and then it stops. So what happened here is the scanner received an input through the keyboard, and then it went to the next line. So here we are calling the stop execution. So here we are setting it to false. So once this value is set to false, in the next iteration when the run method is running, the value is false and the execution comes out of this loop, and that's how the execution has stopped. So here how this came out of the execution is because you are changing the value of the valid boolean here, and still the value is taken by the thread. But what could happen in some scenarios is the boolean value, the valid value, could have been cached by the thread itself. In that scenario, what happens is even if you change the value of the boolean here, it may not get reflected in the cache memory of the thread. So in such scenario, the execution will not stop at all and it will keep on continue. So to avoid that, means to ensure that your thread to read always the latest value of a variable, what you need to do is you need to use the volatile keyword before the variable. So what we will be doing is we will be using the volatile keyword. Volatile keyword. So when you use this keyword, what happens is the boolean value is not stored into the thread local memory, and it will be present in the main memory itself, so that even if any number of threads access the variable, they will always read the latest value of the variable. So that is the use of the volatile keyword. Next we will see what is meant by the synchronization. So here we have an example here, synchronized example that I wrote. In this one, what we did is that we have a counter, its value is set to 0, and then increment count method where we will increment the value by 1. So it's already so let's remove this keyword for now, the synchronized keyword here. So what we do is we want to create an instance of synchronized example, and we are trying to run this method, do the job. So in this one, what we are doing is we are creating two threads. So what these two threads will do is for in a for loop, for int I equal to 0, I less than 10,000, they increment the count. So here also the same thing, even the next thread also same thing, we are doing the same thing, incrementing the count. So if you look at this number, like it is 10,000 and this is 10,000, so from our perspective what we would think is that at the end of the execution we might be thinking that the value of the count will be equal to 20,000. That would be our expectation, but let's see how it prints. And also here if you see the code here that we wrote, t1 dot t2 join t2 dot join. So what happens is when you run this method, it will the main program. So the main thread will call this method and it will start the thread t1 and t2, and then immediately once this program execution is completed, the main program is completed, means the program is shut down. So we will not be able to wait until the thread execution is completed. Okay, so to ensure that our main program is waiting until the threads t1 t2 are completed, what we need to do is we need to write this t1 dot join and t2 dot join. So it means our main thread, I mean when you are running a main program, it means there is at least one thread running and the thread name is main. So that thread will wait for the t1 to complete and then it will wait for the t2 to complete. So that's why we had to write this two statement here, t1 dot join and t2 dot join. So let's run this program and see what will be the value of the counter. Okay, see, instead of 20,000 it printed 19,529. Now let's run again. Okay, it printed a different value, see why the value is changing. So it means, so our expected value is 20,000 but we are not getting our expected value. Why is that? So if you see this increment method, when the thread t1 started and t2 are started, what happens is, for example, if t1 started executing this method, at the time count value is 1. So before the thread could increment the value, what happens is in the thread 2 itself, it has read the value of the count again, and because the thread 1 didn't increment the value by the time thread 2 is reading the value, so the count value remains the same while they are trying to increment. So because of that the count value is not reaching 2000. If you look at this method, even if the statement is a single line here like count equal to count plus 1, from the computer terminology there is lot of things going on here. So there are 3 different steps for incrementing the count. So what computer will do is it is reading the value of the count and then it is incrementing by 1 and then it is assigning the value to count again. So it is 3 steps. So before the assignment, before incrementing and before assigning the value to the count, what could happen is the other thread could have read the value. It means it is not reading the latest value. So in such scenario, can't we use the volatile keyword? So here in this scenario we cannot use the volatile keyword, because volatile keyword can be used for atomic kind of some things that are not changed in multiple steps. So here this method, the value of the count is getting changed in 3 different steps. In this kind of a scenarios we need to use the synchronized keyword. So we will use this synchronized method or synchronized blocks or synchronized what we'll do is, let's write this synchronized keyword here. So this method is synchronized one. So it means only one thread can access this method at a time. So until the value of the count gets updated, the second thread cannot enter into this method, so that they would always read the latest value of the count. So let's run this now and we will see what will be the output. Okay, now it printed 20,000. Now we will run again. Yeah, it still printed 20,000. Yeah, it still printed 20,000. So okay, so this is the expected value for us. So this is the difference between volatile and synchronized keywords. So hope you enjoy the video. Please do subscribe for more videos. Thank you.